Okay, so assuming that we have a surface, and this is it's not a straight line. Assuming that this is a horizontal line, so the horizontal line, and is in a line which will be tangent to the surface of the Earth, and we know that on the Earth the surface, the actual surface is not a flat. Instead, there will be some grays. If there's a one here that we want to measure, and assume that there's a 1 point, the point that we want to measure is point A, and then we can try to define the location of A based on its horizontal distance and the vertical distance, and also the grade. So here, for the vertical distance, it actually represents, also we define them as the elevation. It represents the direct distance from point A to the horizontal line. Don't know why it's not wrong. So the vertical distance represent the direct line from point A to the horizontal line, and of course this line should be perpendicular to the horizontal line, and the angle is around 90 degrees. So this one, the distance of this one is called the vertical distance. And if we want to compare measure the distance from point A to another point, say that point B, and the point B is located in the horizontal line, then we can identify that the distance from point B to the intersect between point A and the vertical line and the horizontal line, say that A prime, as the horizontal line. So that will be the horizontal line. And this distance is called the horizontal distance. We also have another concept, which is called a grid. And it shows the gradients of the line from A to B. And usually we will use the we will define this one as the grade for the line. And the grade could be measured with the angle here, say that the theta. So we will measure the grade by calculating the value of theta as tangent theta equal to the vertical distance divided by the horizontal distance. So that's the way for us to get the to define the horizontal distance and the vertical distance. And so this would be the fundamental definition. And we also have the units we want to use for this class. Basically, in this class, we will use both English units and the metric units. So we will use, for distance, we will use the inch, feet, and miles. We will also use the centimeters, millimeters, meters, or kilometers. And for the angles, we will use the degree and revolution. Or as I explained in the previous lecture, we will have the one revolution as 360 degrees, and 1 degree represents 60 minutes, and 1 minute is 60 seconds. And for the temperature, we will use both the degrees in Celsius and Fahrenheit. You have to know how to do the conversion between the English units and the metric units. And that's the fundamental things we need to know about the measurements. And the last thing we would cover in the previous notes is like for the measurement, the reason for us to introduce the measurement is like in order for us to do the survey, we need to have the appropriate measurement, and to know the angles, to know the distance, and we need to know what's the best way to express the measurements in your lab sessions or in all your future projects. And with that, the other person can easily capture what you are measuring for the project, and how they can reproduce or finish the project based on your measured quantities. And the appropriate expression of the measured quantity is very important. In this class, of course, we will introduce how we can write down or how we can record those measurements appropriately for your analysis in the lab, and to present the result to the other audience. One simple example is like if I give you a simple task like measuring the distance from the Kingston City Hall to GHE building, how we conduct this kind of measurements, and what kind of unit you're going to choose, and what kind of tools you need to use to finish the measurement. So all these things will be taught in this class. So that would be the couple slides we left from the previous lecture. With that, we finished the introduction about the basic concepts in the surveying. And start from this lecture, we will introduce more information about how to conduct the surveying, what kind of tools we need to use, how we can analyze the results, and if there are some errors, how we can mitigate the errors and improve the accuracy. Okay, so that's note 2. Do you have any questions so far about the basic concepts? Okay, if you have any questions, you can raise your hand. If not, we will go to the next note, the measurements and errors. Okay. Remember that you can always raise your hand for any potential questions. Okay, let me switch to the next lecture. So in the actually in the lecture today, I intend to introduce more details about the measurements and the potential errors in the surveying. These two are the most important concepts for you to conduct the surveying project. So first of all, we have to know what is measurement. From the textbook, we can know that the measurement is kind of an act of determining the weight, the length, the capacity, the size, or the other dimensions like the force, acceleration, speed of an aspect of the physical universe. This could be anything that you can measure based on the different tools that you can use. So in order to get an measurement, we definitely need to use some instruments. In this class, we will focus on some simple measurements about the physical world, like the angles and distance, and how to combine them together to design complicated projects. So the tools we're going to use in this class will be limited, but there will be a lot of other instruments that can be used, and you will probably learn how to operate them in the future. To select the instrument, the quality of the instrument is very important. For example, if we want to measure the distance, you have to decide whether you're going to use the tape, which is relatively precise. You can also use some digital measurement tools. But you can also, if you don't have these tools, you can use your pace to do the measurement, which will be one major task of our first lab experiment. With this kind of comparison, you can see that if you just use your pace, definitely there will be a huge error there. But if you rely on the tape, the error could be reduced a lot. And if you use some digital tools, you can reduce the error to less than 1 millimeters, or even smaller. So the quality of the instruments is very important. With the quality improved, the uncertainty of the measurements will be reduced, and also you will have a higher accuracy of your measurements. So let's take a simple example about how to measure a distance. To measure a distance, this process is very simple. First of all, you need to choose the tape and set up the tape along the line you want to measure. At first, you need to align the 0 mark to one end. Well, we can say that to the left end of the line, and then stretch the tape until you reach to the right end where you want to measure, and then read the scale in the tape, which will be and that value in the tape will be the distance that you measured with that tape for the line. So this is a very simple process. Like for this example, if you are using the tape, you can measure distance around 40.3 centimeters, and it could be some other values depending on the line you are trying to measure. For the measurement, in order for you to read the results to get the measurement, we have to read the value from the instrument, and that reading is called the observation. And of course, if you have multiple surveyors to do the same measurement, you will have different readings. Well, everyone has some uncertainties about the minimum scales from the instrument. So the result will be a little bit different. Generally, this observation will not be exactly the same to the true values. So we need, as a surveyor, one of the major tasks is trying to find out how we can solve this kind of uncertainty, and how, if we know there are some errors, how we can solve it. And also, there will be some potential errors. The difference between the true value and observed value could be caused by the mistake of the surveyor. If it's that case, you may need to redo the experiment and try to solve any human errors. So if we are talking about observation and true values, then definitely we will have the errors, and the errors is defined as the difference between the true value and the observation. And in the surveying, generally, there will be 3 types of the errors. The first one is called the gross error. This could be the mistakes from the surveyors or from the blunders from your readings. The reason for this type of the errors could be the carelessness of the surveyors, could be the failures of the equipment, or the misinterpretation of the readings. Sometimes you have the right reading, you have the right measurement, but you read the results, you explain the reading with the maybe with the wrong units, and with that one you will have some errors. And in order to correct this type of the gross errors, the best way for you to do is I need to take multiple independent readings and check the reasonable consistency. If there's an outlier from multiple readings, definitely this outlier would be the wrong reading, and that should be the one observation you have to exclude. And also, you can use some simple and quick technology to do the verification. For example, if we just want to measure the distance, you can try to check measure a known distance first, and see whether you use the instrument correctly and whether the instrument is also accurate to measure the distance. In addition, you need to check and verify the performance of the equipment. Make sure that you follow the right manual to operate the instruments. That's probably applied for the digital instruments. And repeating the experiment many times and do more recording about the multiple recording about the same observations. Make sure that you have the observation consistent. So that's the way for you to minimize the potential gross errors. And the second type of the error is called the system errors. And this one is usually caused by the instrument itself, or there will be some habits from the surveyors. And usually this kind of errors cannot be avoided. But the good thing is like we will have some way to solve it. Generally, the system errors will have two characters. First of all, the system error will have the pattern. So if you find that the tape will always measure some distance with smaller value, then you probably have some errors for that tape, and you do that one. You do the measurement for one distance measurement, you have the shorter value, and you do that one for another distance measurement, you will also observe the smaller value. And the second character is the error is duplicable, which means that if you repeat, even you repeat the measurement for many times, you will still observe the similar results. And the result is always like if it's smaller, then it will always be smaller. And usually this kind of error is caused by the some natural environment. For example, the temperature. If the temperature is high, your measured distance will tend to be smaller. And also there will be some some impact from the moisture level and also the force. The instrument will also have some impact by itself. Like if the scale in the instrument is not marked correctly, it will also have some wrong readings there. And also it could be the limitations of the human surveyors. For example, if you someone may have limitation to read the smallest scale, or they have the habit to always read the lower bound, something like that. This will also has the some reason for you to get a systematic error. So to do the to correct the system error, what we're gonna do is like we can use the instrument to measure some standard values and then compare the readings with the true value. With that, we are able to identify the differences and then use these differences, which we also call the correction, to modify the observations in the future projects. And with that, you are able to fix all those systematic errors. So to do that, for the systematic error, we actually defined several concepts. Here, assuming that X is the corrected or the true value of the measurement, and X is the observation of the value. X is the observation, and then we can define ES as a systematic error. So ES will be the difference between the observed value and the systematic value. So we will have ES equal to X minus XC. That will be the true value. And we can also define the correction. Usually the correction is defined as the negative ES, which will be the true value minus the observed value. In addition, we can have the residual, which is defined as the difference between the estimated value and the observed value. So so we have D equal to X hat minus X, and which is equivalent to the case like X hat just a moment. Let me try to just bear with me. I think there will be some issue about the my pen. So we will have the let's continue the introduction about the estimated value and residual. So residual is X hat minus X, and this one is equivalent to the case like X hat equal to X minus the residual. So usually the estimated value, if we only have one observation, the estimated value would be the observation. But if we have multiple observations, the estimated value would be the average of all those observations. So that's the system error, and you can see that if we apply the correction, we are able to change the observed value to some value close to the true value. So that's the good thing, which means that we are able to remove the systematic error from our measurement. So any questions for now?
I'm sorry, can you read the errors equations one more time, please?
Which one?
So like the ES one and I think the C one.
Yes. Sorry, my paint's not working very well today, so just bear with me if there's some typos there. So ES is the systematic error. It will just be the error between the true value and the observed value. So that is X minus the true value. And the correction is very simple. Correction is actually negative of the ES. So so that's the definition about the systematic error. So any questions? Okay. So if the if that's clear, then we move to the next error, which is the most common error, and is the error that you cannot avoid in your field experiment and for most of the surveying projects. And that's actually the error we have to always handle in reality. So that one is called the random error. So the error, this is caused by the multiple observations. So we know that for the surveyor, even you are very you can observe the scales very well, and you you have a very accurate instrument, but you will always make any when you do the readings, there will be some uncertainties about the when you're trying to align your instrument to the target, and this kind of uncertainties will be hard for you to identify, and is not like the system error, which you can do the adjustment about the instrument. It's not like the gross error, which you can do with repeating measurement to exclude them. And this one is random. It happens at every observation. And if you get multiple observations, you can find that it does not follow any pattern. It's randomly distributed around the true values. So the with this error, we need to find a method, which means that we need to rely on some statistical methods to minimize their impact for our measurement. And in order to quantify the random error, we define a new term which is called the discrepancy. And the discrepancy is related to the observations, the multiple observations. So I should say that we will have the two observations, x1, which will be the result from the first observation, x2, that will be the result from the second observation, and the DC will be is defined as discrepancy, and the discrepancy is defined as the difference between these two values. So DC will be x1 minus x2. It will always shows how far the two observations are to each other. And this is only the case for two observations. But if we are talking about the case with a lot of observations, then we need to find out a better way to describe the random errors. And in the statistics, one way for us to describe the random error is using the probabilities and the random variables. So here I will give you a brief review about the random variable and the probability. So the random variable is defined as a variable that takes on several possible values, and for each value, it has the probability. So here we have the concept which is called a probability, and the probability is defined as the number of the chances for the success divided by the total number of the chance, or as the limited value to which the relative frequency of the occurrence tends as the number of the repetition is increased indefinitely. So this, to make it simple, the probability indicates that what's the chance for you to get the value under a sample. And there will be one simple example to show you what's the random variable, what's the probability. So here, if you do an experiment, for example, if you flip on a coin, and the result could be either front or back. So this is actually a random variable. What's the result for you to flip on a coin? Before you do the experiment, you have no idea what's the result. It could be front, it could be back. There will be a certain chance for you to get each value. And for example, if we do the experiment, flip the coin for 100 times, we found the 53 times with the front and 47 times with the back. Then we can define or we can estimate the probability of the front based on this experiment as the probability of front would be 53 over 100. So that is 0.53. So it indicates that if you flip this coin, well, based on the experiment that you have already done, you have 53% to get the front result. And similarly, you can find out the probability of back. That would be 47 divided by the total number of the experiments is 0.47. So that means that the percentage is 47 for the back. So those would be the probability of the front and the back. If you add these two probabilities together, you can find out the result will be 1. So that indicates that you will have a 100% chance to either get the front or the back result. So there are only two results for you to flip on a coin. So that's the one simple example about the random variable. I will just stop here for a while to see whether you have any questions.
Professor.
Yes.
I had a question. In which textbook can we find this information? Because in the first lecture, you like mentioned a few textbooks, and I'm just wondering which one, like, I can find this stuff in.
Oh, the regarding to this review session about the probability, you can actually find out the one. Let me go to bring out the first lecture. So in the first lecture, in the first textbook, the surveying theory and practice. I don't have a textbook with me for now. It's in the there's one chapter to discuss the errors, and there will be some information about the random error and the introduction of the probability.
Okay, thanks.
Yes. So I would well, we don't have enough time for the rest of the topic. So I would like to check all the questions that you have in the meeting chat, and if you have any questions, you can raise your hand about the any of the current assignment. I actually browsing some questions about the homework assignment. The first homework will be assigned maybe tomorrow after finish the lecture, and you will have 1 week to work on the homework assignment. So bear with me about my handwriting for this time. I actually lost the power of my pen, so the handwriting it's not that good. For the homework assignment, it will be I see the question about where you can find out the homework assignment. The homework assignment will be uploaded to Avenue to Learn. You can check the assignments under the I think what's the let me try to find out the so you can let me go to see the Avenue to Learn. Your interface might be a little bit different from mine. So if we go to see the class, you will see the assessment, and there will be homework assignment, and the assignment will be uploaded tomorrow. And once it's uploaded, you should receive the notification from Avenue to Learn, and you can download the homework sheet and work on that. Once you finish your homework assignment, you need to upload your I guess this time you have to scan your solutions and upload this one to the to Avenue to Learn. Is also under the assignment. You will have the Dropbox to upload the all your answers, and there will be some instructions in the homework assignment about how you're gonna name your solution and what's the deadline for each homework assignment. Let me see whether you have any other questions. So the usually if we just go through the questions from bottom to top. I'm not quite sure what it is. So the for the deadline of each homework assignment, usually I will assign the homework on Thursday, and the deadline will be next Friday. it will give us some time. It will give us some time. Give us some time to for the TA to download your assignment, and the TA can grade your homework over the weekend, and probably we will return everything back to you on the other Tuesday or Wednesday, depending on the number of the questions assigned in each homework. Okay. Well, I will try to end the lecture today a little bit early because there are some issue about my pen, and I cannot write down the some equations in my slides. We will continue these notes by introducing more details about the random variables and how to use the random variables to represent the your measured results. And those information will be applied for you to do the field experiment to process the results that you observed from the field experiment. We will have more details in the next lecture. Okay. If we don't have any additional questions, I would like to end the lecture today. And let me know, send me email if you have any questions, and I will, or you can send a message to me through Teams. Okay. Oh, by the way, don't forget to check the lab group list on Emily2Learn. I will upload the list just in a couple of minutes. Okay. Well, that's good. Thank you very much for your time, and I will see you tomorrow.